I mean, the first step, you go evaluate the circuit to see what V of infinity is and V of 0.
Absolutely wrong. Completely wrong. You are trying to solve this problem as if it were a DC supply. That equation I gave you only applied for a DC supply. This is not a DC supply. So if you can't do it by the equation I gave you, because that equation I gave you is for a DC supply, how else can you do it? Well, I only taught you one other method, and I taught you that on Friday. What was the method I taught you on Friday?
I am teaching us how to find VS.
I don't know why students leave off the of. It's not VS, it is V of S. If you don't say things the way they're supposed to be said, then you think about those things the wrong way. VS is different from V of S. Yes, we have to go to Laplace Laplace plane, the Laplace domain. Okay, so what does the supply become? What does the supply become?
Do you just put the voltage over S or no?
Would it be 10 sine 2t over S? Yeah, just put everything over S.
Yeah, is that what I taught you? Did I teach you that? No, I did not teach you that.
No, sir.
I taught you that when the DC supply when the supply was DC, because then it was a constant, and the Laplace of a constant is that constant divided by S. The supply is not a constant. So what does the supply become?
The supply become 10 T over S squared plus 2.
Mr. Beauchamp, I believe that was.
Yes, sir.
Is that Laplace? Is that how you find the Laplace of sine 2t? After all the work we did, well, I take that back, all the work I did, because apparently y'all done buckets. Y'all haven't done any work on Laplace transforms. I remind you again that the final exam is a week from Friday. And y'all still haven't learned how to do Laplace transforms. Well, all I can say to you is good luck to you on Friday. Good luck to you a week from Friday. How do you find Laplace of 10 sine 2t?
So, Mr. Cartwright, it won't be 20 over S squared plus 2.
Yeah, but that's not what you said. That's not what you said. That's not what you said earlier. You're now giving me the correct result. Of course, it is 10 It is 10 times 2 divided by s squared plus 2 squared. Because that's how you apply, that's how you find Laplace of 10 sine 2t. And of course, we can simplify that to 20 over s squared plus 4. What does the resistor be? Yes, go ahead.
So y'all, that was T5 y'all used, correct?
Yeah.
Thank you.
What does the resistor become? What does the resistor become?
1,000 over S.
Really? Is that what we did on Friday?
I remember using the divider rule. Well, the divider rule.
But Ms. Beauchamp, you have to remember everything we did on Friday. And it's clear to me that y'all did not study what we did on Friday. And again, I say to you, good luck to you.
From what I see, the resistor value didn't change.
The resistor remains the resistor. Thank you very much. What does the capacitor become?
I know that one is 1,000 over S.
And where does 1,000 come from?
When you
Is somebody saying something? Ms. Beauchamp, did you start to say something?
I ain't say nothing.
Oh, I thought I heard somebody trying to say something. I asked you, somebody said the capacitor becomes 1,000 over S. Where did 1,000 come from?
Is it because it's in series with the resistor?
No, absolutely not. It's got nothing to do with how it's connected.
No, where the 10 came from, where the 2 came from.
I'm sorry, the last person you broke up. Try again, please.
Hey, Dr. Cadre, story. I was just wondering where the 2 came from in the numerator when we times it by.
It came from the numerator. It came from the numerator. What numerator? The numerator of what?
Talking about the 10 times 2. Where the 2 came from.
Mr. Who's talking?
Rule.
Who? Who was the last person to talk, please?
That was Rule, sir.
Mr. Roll, I am not talking about the sauce anymore. We passed the sauce. We're not talking about the capacitor. I asked you, what did the capacitor become? And somebody answered correctly, 1,000 over S. But he can't tell me where he got the 1,000 from. Where did the 1,000 come from?
Would that be the value of the resistor over S?
Mr. Johnson, somebody just said that. I told him no. The value of the capacitor in the Laplace domain has got nothing to do with the value of the resistor. It's just coincidental in this problem that they're the same. But I gave you the formula. I gave you the formula on just Friday. It's clear that y'all ignored my advice. You did not study what we did. I gave you that formula.
That's because we convert the microfarads.
Give me the general equation. What does the capacitor become generally? In the Laplace domain, what does the capacitor become? Look in your notes, folks. Down, this is a light, lazy class. Look in your notes from Friday. I told you what the capacitor becomes.
And then you said it becomes R2.
No, that was another example. It does not become R2. There's no R2 in this circuit.
Godric, I don't know if I wrote this wrong, but I saw 1,000 over SC.
No, you did write it wrong. You did write it
use the
wrong.
voltage divider rule in that situation?
Young man, we're not at voltage divider stage yet.
Okay.
We're still trying to determine what the capacitor becomes. I don't know why y'all don't listen to my questions and stop answering questions I didn't ask. The capacitor in the time domain becomes what in the Laplace domain? That's the question I'm asking. In other words, I'm asking, what is the Laplace of the capacitor? And I gave you that formula, and clearly you all just ignored it. The capacitor becomes 1 over SC. 1 over SC. Okay. And C is 0.001. Because it's 1 millifarad. Therefore, that's the same thing as 1,000 over S. That's where it came. That's where the 1,000 came from. It came from the value of the capacitor. The capacitor in the time domain becomes 1 over SC in the Laplace domain. I made that very clear on Friday. But you all didn't bother learning it. And apparently you all didn't bother putting it in your notes.
You end up squatching.
Excuse me?
I was saying in the notes, you end up squatching the CO.
Because I put 1,000 on top. But the general rule is S becomes 1 over SC. You've seen that in 235. But in 235, we weren't talking about the Laplace domain. We were talking about the phasor domain. It's the same formula. Are we clear on what the capacitor becomes?
Yes, sir.
Okay. What does VFT become? What does VFT become?
Would that be equal to V infinity?
Yo, man, you way off. You way off base. You are way off base. V of infinity is in the time domain. V of 0 and V of infinity are in the time domain. I'm not talking about the time domain. I'm asking you, what does V of t become in the Laplace domain?
Oh, my bad. Now
Vs.
this
Mr.
we gotta
Buchan,
use
Mr. Buchan,
gotta use
what were you
fault type.
saying?
I was saying if it was V of S,
Yes, it's V of s.
and that's when you use voltage divider.
Now we can use voltage divider for this circuit, not for every circuit. For this circuit, we can use voltage divider, and the one we did on Friday. But that's not always going to be true. This 1 over SC, that's an impedance. And 1,000 ohms is another impedance. Excuse me?
Dr. would you do like an example after this? Like if we don't have to use the situation where we won't be using the voltage divider rule.
Young man, let's get through the voltage divider rule, because clearly you didn't learn this on Friday. It boggles my mind why students want to do something else while I'm teaching a particular subject. Let's get through this problem. Now, what we have here is two impedances in series connected to a voltage source. Hence, we have a voltage divider. And hence, we can use the voltage divider rule. Just like we did on Friday. So V of S equals what? Well, I take that back. Just like I did on Friday, because clearly y'all haven't done anything. What does V of S equal to?
That's 1,000 over S over 1,000 plus 1,000 over S.
Times 20 over S squared plus 4.
And this first ratio can be simplified by dividing by 1,000. You don't have to do that, but just makes the math easier. And then multiply on top and bottom by S. Okay, so that's V of S. So now how are we going to find V of T? How are we going to find V of T now?
We would use inverse Laplace.
No, we're not there yet. Eventually
Eventually
will.
You're looking for the time domain now.
No, that's when you have to use the A over something plus the B over.
We use partial fractions expansion. We use partial fraction expansion. So what's the order of the denominator? What's the order of the denominator? What's the order of S?
Can you put A over S plus 1?
Folks, why don't you all answer the questions I ask?
You say what's the order? The order is S plus 1.
The order is not S plus 1. The order is an integer.
I see to the power 1 and to the power 2.
What you doing with an S and S squared? What are you doing with those two things?
I guess we could expand and make that into a cube.
Yes, it becomes cubed. So what is the order of denominator?
That'll be third order.
Yes. Yes, the order is 3. That's a cubic equation on the bottom. S times S squared is S cubed. So how many unknowns we gonna have?
Got off 3, A, B, and C.
A, B, and C. So this becomes A over S plus 1 plus BS plus C over S squared plus 4. If you recall, all the quadratics we looked at can be written of the form BS plus C divided by the quadratic. I'm going to write that as D. Okay. Therefore, when you're expanding in partial fraction expansions, when you're expanding with a quadratic, you have to expand it that way. And now, what's the value of A? What's the value of A?
A will be 20 over S squared plus 4, evaluated as S equal -1.
Yes. So that becomes A equals how much?
20 over -1 squared plus 4. Let me get my calculator.
And how much is that? 20 over 5. 20 over 5,
4.
which is 4. All right. I'm going to move this so everybody snip it. So now how am I going to find B and C? How am I going to find B and C?
Dr. Carter, is 20 supposed to be in the numerator?
Yes, thank you. Yes. Good catch. How am I going to find B and C?
We're gonna have to use the quadratic formula.
Really? To find B and C? I don't know why this class will not study.
Wouldn't it been easier to simplify it when it was on B over S squared plus 4 plus C over S squared plus 4? I know we're doing it this way.
But that ain't what we have. We do not have B over S squared plus 4. We have BS over S squared plus 4. All you're saying, can we split this into two? And the answer is yes. But that ain't going to help you any, not yet. Folks, what did we do in the past? You don't know because you don't study. I don't know why a student level class thinks they don't have to study. We multiply both sides by the denominator. We multiply both sides by the denominator. So this becomes 20 equals 4 times s squared plus 4 plus bs plus c times s plus 1. So that becomes 20 equals 4s squared plus 16 plus bs squared plus bs plus cs plus c. 20 equals 4 plus b s squared plus b plus c s plus c plus 16. So right off the bat, 20 must be equal to c plus 16. So c must be 4. What's the value of b? What's the value of b?
And it'll be b plus c, close bracket s equals 0.
Yeah, you could go that way, or you could simply look at this. This must be 0, right? 4 plus b must be 0. Why? Because all on this side is 0s squared plus 0s. So 4 plus b must be 0, and b plus c must be 0, just like we did last class. So b equals negative 4 because 4 plus b equals 0, or b plus c equals 0. So b plus 4 equals 0, b equals negative 4. So now we know this is 4 over s plus 1 plus negative 4s plus 4 over s squared plus 4. Okay. Now what?
You probably could start finding the inverse of Laplace.
All right. All right. So b of t then becomes inverse Laplace of 4 over s plus 1 plus inverse Laplace of negative 4s over s squared plus 4 plus inverse Laplace of 4 over s squared plus 4. which is how much? Which is how much?
I know the first one is 4e to the minus t.
Yes. What's the second one? Oh, what's the second one?
Well, the second one is cosine. That'll be 4 cosine.
No, -4.
Yeah, -4.
-4 cosine what?
2t.
2t. Good for you. And again, that'd be times u of t. And what's the last one?
That'll be plus the same thing. Plus 4,
Plus what?
4 cosine 2t u of t.
Miss Beauchamp.
No, I won't get that. Sorry about that. I didn't get that. That is be sine.
Yeah.
Yeah, so that's 4 sine 2t.
Somebody else help him.
Wouldn't that be 4e to the power of 2t?
No, Mr. Johnson. No, you're going off on a tangent. A tangent is going to take you to Venus.
So the Einstein because 4 in the numerator. If it was 2,
all right. So what you gonna do about that?
You bring up the fraction, so it could be 2 over or a half sine.
No, it's 2 times 2, isn't it?
Yeah. So it'd be 2 sine.
Yes.
2 sine 2t.
Yes. Now it's clear to me that y'all still don't know how to do Laplace transforms and inverse Laplace transforms. Okay. And you don't have very much time left to learn it. Get off your asses and learn it. You will need this for the final exam. All right.
You can't print the table on the exam.
No, I told you I'm not going to let you have the table on the exam. There's some basic transforms that we all as engineers need to know intuitively. And I told you from the break to learn that table. And you think you don't have to listen to me. Well, you don't have to listen to me until the final exam. And then if you don't know it, you get to do this course again.
Dr. Cadre, how much more material we have to cover before the final exam?
We have to, every day from now until the Wednesday before the final exam, we're going to be busy.
You still giving the assignment?
I'll give it an assignment.
Today or?
I ain't promising today, but soon.
I have a question.
Yes, go ahead.
Why did you decide to change that 4 and bring the 2 in front? Yeah, why did you decide to do it like that?
Because this is the thing that's in the table.
Oh.
It's omega divided by s squared plus omega squared. All else could you have done? Okay, good. Now let's write this here as one sinusoid. I showed you how to do this. You need to know how to do this. I showed you how to do this. Okay. I told you this is sine 2t. This is cosine 2t. This is minus sine 2t. And this here is negative cosine 2t. Okay. So this here is -4. So that's this one here. That's this one here, down here. Okay, and it's 4 long. Okay. And sine 2t, that's a long here, and it's too long. It's too long. And so what is the resultant? The resultant is this. And so that would be Pythagoras. This length here would be Pythagoras. The square root of 4 squared plus 2 squared equals square root of 20. And then the phase would be negative of that angle. And that angle by basic trigonometry, let's call that theta. Tan theta. Okay. Tan theta is opposite. That's 4 over adjacent, 2. So theta equals inverse tan of 2. Excuse me? Okay, good. 63.43 degrees. And that angle is negative compared to sine of 2t. Therefore, this is 4 e to the minus 2, sorry, e to the minus t, okay, plus the square root of 20 sine of 2t minus 63.43 degrees volts. Okay. That's the first way I showed you how to do this inverse Laplace. Before I go on, any questions about this? And if you don't want, go ahead. Something on page what? And what is that?
Got right.
You don't understand this expansion? You don't know how to expand a polynomial? That's high school. You don't know how to multiply these terms? So what's your question? I don't understand your question then. That's all we did is go from this line to this line here. All we did was multiply these brackets. That's all we did. And then go from here to here. All we did was group like terms. Group all S squared together. This is S squared, that's S squared. So that becomes 4 plus B. Okay. This is BS and that is CS. So that becomes B plus CS. This is no S and that's no S. So it becomes C plus 16. We're just grouping like terms. Okay.
Dr. Godray.
Yeah, yes, that's a 20. 20. Well, that's where this 20 come from.
Hey, Mr. Godray, Dr. Godray.
Yes, go ahead.
I see you write that in page 3. I see you write that. I see you write that in sine. I could also write that in cosine form if I wanted to, right?
You mean this very bottom one?
Yes, sir.
What would the answer be?
I'll be square root of 20 cosine.
What would the angle be?
Angle will be, let me subtract that first. $63.43. angle will be 26.57.
Absolutely not.
No?
Totally wrong.
No. I see where you're going wrong.
If you go from sine to cosine, you have to subtract 90 degrees. Because his cosine, look at the screen. His cosine, you want this angle. And clearly you have to add 90 degrees to theta. And then you have to subtract this entire angle. If you want to write it in terms of cosine. And yes, you need to know how to do that. Any other questions before I go on?
When would we know to use this?
I don't know what you mean by this. What this are you referring to?
The last thing you just did. At the very bottom of the page with the angles. Fine and tan, fine and theta, yeah.
No, man, what did we do? Why did this need to come up? Why did I refer to this?
I wasn't too sure, that's why I didn't want you move on and me get confused. I was still writing notes. Yeah.
Okay, let me translate that. You weren't paying attention.
Not as much as I should have. That's all.
We were adding negative 4 cosine 2t to positive 2 sine 2t. That's what we were doing. I'm not going to re-explain everything I explained just 5 minutes ago. If you don't pay attention, that's on you. That ain't on me.
Thank you, Dr. Carter.
I don't know why you're so interested in writing down what I write down when you could simply take a snap at the end of the page. Your primary goal is to pay attention. That's your primary goal. Now, if I was writing on chalkboard, I could see you be concerned about copying notes as I wrote the notes. But that's not the technology we're using now. Your primary goal is to pay attention so you see what I'm doing. And if I do a step you don't understand, then you ask me that question right away. And then at the very end of the page, you can simply snip it. I think students think, go ahead.
I was saying I could do that. Yeah.
All right. Now let's go back. Let's go back and do the inverse Laplace another way. Let's go back and do the inverse Laplace. Okay. So this is V of S. Okay. So V of T then is going to consist of two parts, V1 of T and V2 of T. And clearly in this context, V1 of T is the inverse Laplace of that, which we found out to be 4 e to the minus t u of t. And V2 of t is inverse Laplace corresponding to that. But I showed you last class a simple way of when you have a quadratic of getting an inverse Laplace. And let me remind you of what I showed you. You look at the quadratic, s squared plus 4, and what do you do? If that quadratic has complex conjugates, then this method would work. And indeed, what are the roots of this?
That look like J2, a negative J2.
Yes, roots are J2, a negative J2. And what's the shortcut method I showed you? What was the shortcut method I showed you for involving quadratic, involving a quadratic with complex roots? Again, we did this last class. I don't know what you're talking about. Say again, please, what you just said to me. A over. Yeah. That? Of course that got to do with anything we're talking about. You see a quadratic there anywhere? You see a quadratic there anywhere, young man? And you better say no. Therefore, how has that got to do with anything I'm talking about? I'm talking about there has to be a quadratic with complex roots. You don't even have a quadratic. I think students, go ahead.
Will that have something to do with like Q of S?
Absolutely.
Then it'll be
what is Q of S?
Q of S will be 20 evaluated at.
No. Remember what I told you Q of S was originally. What did I tell you Q of S was originally? I didn't tell you Q of S is the numerator.
No, it'll be V of S, the denominator. V of S times probably S squared plus 4.
Yes. Or an easy way of saying that is V of S except for the quadratic part. So it's 20 over S plus 1, leaving off the quadratic part.
Oh, all right. It'll be evaluated at S.
Evaluated at S equals?
You know alpha in that, so that'll just be J2.
J2, very good. Okay, so let's do that. So that becomes 20 over 1 plus J2. So that's 20 over square root of 5. And what's the angle? What's the angle?
63.43.
Yes. So it's 20 over root 5. What's 20 over root 5? What's the angle? What's the angle? Folks, y'all can't tell me what the angle of this is? $20 is the same thing as 20, 0. So does that help?
minus 63.43.
Negative 63.43. Yes. So this is M, and this is theta. Okay. So now what's V2 of t? What is this part? It's M over omega e to the minus alpha t sine of what? Omega. Yes. So omega t plus theta. So this now is 4, times u of t. Excuse me? Excuse me? So M is what? 8.944 divided by omega. Omega is 2. Alpha is 0. So this part becomes 1. E to the minus 0 is 1. Sine of 2t plus theta. And theta is negative 63.43. And so finally down here, I'm going to write V of t equals 4 e to the minus t u of t 8.944 divided by 2, 4.472 sine 2t minus 63.43. And this is exactly the same thing we got earlier by the other method. See there? This is square root 20. What's square root 20? It better be 4.472. And it is.
All right, but this only is work for case 3, right?
This only works for case 3, absolutely right. But I showed you what you have to do in case 2 and in case 1. I showed you that. Any questions about this? Okay. So here's a problem we could not have solved in 235. In 235, we could have solved for what part? We could have solved for this part. This circuit, we could have solved for this part using phases. But we would have not gotten that part. By the way, this part here is called the transient part. The transient, and this part here is called the steady state. What does transient mean? In English, what does transient mean? Wow. We don't know vocab. Nobody can tell me what transient means in English. Nobody wants to guess. Transient means something that's only momentary, something that does not last, or something that lasts for a very short period of time. It's transient. Whereas steady state means it's always there. So this is the part, the steady state part, we could predict just using phases without knowing Laplace transforms. But the transient part, we cannot predict. We cannot predict without using Laplace transforms. Drop my pen. Where the devil is it? Oh, Lord. Okay. Any questions about this? All right, let me say again. I am a professional. What does that mean? It means I make stuff look easy. You see somebody doing Kung Fu on